Hey guys, I'm going to cover the electric field worksheet, or at least a few of these problems, so you got to get a hang of it. The whole point of this is to further analyze charged objects. Okay, we know if an object is negatively charged, it has a surplus of electrons. If it's positively charged, it has a deficiency. Okay, it's all about the electrons. Follow the electrons. Okay, now I've given you the charge of an electron. That's all we need. Okay? If we have that, we can figure out how many electrons is of a surplus or a deficiency. Okay? Because we know what charge it gained or lost, right? So if it gained 4 coulombs or it lost 4 coulombs, we can say that it gained electrons or lost electrons, and we can figure out how many were actually lost or gained. Okay? And let me show you how that's done. So number one, it goes from a 0 coulomb charge to a 4 coulomb charge. That means it gained 4 coulombs. Okay, it's becoming more positive. If it's becoming more positive, you're losing electrons. Whoops. You're losing electrons. So I'm going to circle lost. Okay, now, by how many? By how many? Let's start here. It gained a 4 coulomb charge. That's our given. All we have to do is utilize a charge of 1 electron. Just set up a unit conversion. Times. We know that 1 electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. If you go ahead and do this, coulombs cross off. 4 divided by 1.6, or negative 1.6 times 10 to the negative 19th, and you will get something like negative 2.5 times 10 to the 19th. Now, how this reads, this negative sign means you lost, right? So in this case, in order for an object to move from a 0 coulomb charge to a 4 coulomb charge, it had to have lost 2.5 times 10 to the 19th electrons. Okay. Now, I'm okay with you guys writing your answers without the negative sign and to say you lost that many. That makes more sense. That's easier to understand. Just know that negative sign means that it was lost. That's all. All right. Okay. Now, let's move to something with micro. Let's do number 3. So, it moves from a 0 coulomb charge to a 9 micro coulomb charge. Okay. So, remember, this micro means 10 to the negative 6th. So it's moved from a 0 coulomb charge to a 9 times 10 to the negative 6 coulomb charge. Now, remember that negative 6 just means it's a decimal. It's not a negative value. So we actually still have lost electrons because it's becoming more positive. 9 times 10 to the negative 6 is still bigger in magnitude than and value than 0 coulombs. Okay? So we're still gaining coulomb charge, which means we're losing electrons. Now, by how many? Start with your given. 9 times 10 times negative 6 coulombs. Okay. So if your unit conversion. All right. In 1 electron, there exists negative 1.6 times 10 to the negative 19 coulomb of charge. Coulombs cross off. Okay, and I'm going to do this on my calculator for you guys, because I haven't done it yet. All right, and I get negative 5.6, and let's call it 3 times 10 to the 13th. Oop, that's a negative. Get rid of that. 13th electrons. Okay, remember that negative sign. We can disregard it because that means it's lost. So we lost 5.63 times 10 to the 13th electrons in order for this object to move from a 0 coulomb charge to a 9 microcoulomb charge. Okay, and that makes sense based off our last answer. Take a look. Okay? It should be exponentially smaller by a magnitude of 6. And look, it is exponentially smaller by a magnitude of 6, right? All right. Let's move on. Let's do something with nano. I like this. Let's do number 6. All right. Goes from a negative nanocoulomb charge to 0 nanocoulomb charge. Now, nano is 10 to the negative 9th. All right. So it moves from negative 6 times 10 to the negative 9th to 0 times 10 to the negative 9th, which is obviously 0. So what has happened here? Okay, is it becoming more positive or is it becoming more negative? Well, if you're going from a negative to 0, you're becoming more positive. Okay, so I will rewrite this by how much? What coulomb charge? We gained a 6 times 10 to the negative 9th coulomb of charge. Okay, because I've used that as nano, right? All right, now, if you're becoming more positive, remember you're losing electrons. You're losing electrons. Okay. Now, by how many? Remember, this is your starting point. This is your starting point right here. Okay, so start there. 6 times 10 to the negative 9th coulombs. Okay, times, in 1 electron, there exists a 1.6 times 10 to the negative 19th. Let's make it negative. Coulomb charge. Coulombs cross off. We're doing this divided by that. Let me get this for you real quick. 6 times... Here we go. We get negative 3.75. Negative 3.75 times 10 to the, should be the 10th, right? Yep, should be the 10th. And this is electrons. Remember, we can get rid of that negative and just say we lost 3.75 times 10 to the 10th electrons in order to move from a negative 6 nanocoulomb charge to a 0 nanocoulomb charge. Okay, I'll do one more. Let's do number 7 because I had a couple questions on number 7. Now, this moves from a negative 2 nanocoulomb charge to a negative 5 nanocoulomb charge. So it's becoming more negative. If it's becoming more negative, then guess what? You're gaining electrons. You're gaining electrons. Okay, well, you're gaining electrons. Well, how many coulombs of charge have you gained? If it went from negative 2 to negative 5, that's negative 3, if it's nano, times 10 to the negative 9th coulombs. Okay. Negative 3 times 10 to the negative 9th coulombs. That's how much coulomb of charge you've gained. Okay. All right, now, why do we have to move it to coulomb? Why can't we just leave it as nanocoulomb or microcoulomb? Well, that's because the charge of 1 electron is in coulombs. Okay, so we want to keep our units consistent. So 1 electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. Coulombs cancel off. I can kind of do this in my head, but let's get the exact answer. Let's do... All right, we get I'm gonna call it 1.88. 1.88 times 10 to the 10th. And since you're gaining, we can just say gaining or gain 1.88 times 10 to the 10th electrons. Okay, so if you have any more questions on this, do not hesitate to email me. Hopefully this helped. All right, guys.